Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Today's topic is Kepler's laws of motion. Hello students, in this video we'll discuss about three laws of Kepler's related to planetary motion. So let us see what Kepler said about the laws and motion of planets. Let us start with Kepler's obviously planetary motions. Kepler provided three laws. One is the three laws. So I'll discuss one by one. Law number one. It is the law of orbit. The law of orbit. It says that all the planets revolve around the Sun in elliptical orbits, with Sun being at any one of the foci. That means the Sun has to be at any one of the focus. If I have ellipse like this and these are the two focus, the Sun has to be somewhere between between the two focus, and the planet has to move around the Sun in this elliptical orbits. This distance is say this is the semi-major axis and this is the semi-minor axis, major axis, and this is the minor axis. In ellipse we have a major axis and we have a minor axis. This distance is semi-major axis. Anyway, so this is talking about this law of orbit, that planets move in elliptical orbit and Sun has to be at any one of the foci. The second law is about the law of second law. Law of equal areas. Laws of equal areas, that means that let me explain to you first, then I'll write the statement, or I'll write the statement first. It says that every planet or a planet every planet sweeps out equal area in equal interval of time. That is the statement. The meaning is that if I have an ellipse over here, the Sun is here, the planet is here, moving from here to here. This position to this position, 1 to 2, and this is the area that is swept. How much area is covered? The area covered moving from here 1 to 2 is this much area. This is the area swept. Suppose this area is A1, and suppose that the planet is here now and moving from here to here, and how much area is swept now? This is the area covered while moving from, say, position 3 to position 4 along this path. If the time taken from 1 to 2 is t, and the time taken from 3 to 4 is also t, if the time is same, then this area swept A2 is also should be same. This is the statement of, or this is the law. that a planet sweeps out equal area in equal interval of time. That means if the time interval is same, then area has to be same. That means A1 has to be equal to A2. Or I will write that, suppose that it is T1 and this is T2. If statement says if time is same, this implies area has to be equal. Same interval of time, same area. So from this we write the expression for areal velocity, that is the rate of change of area with time, dA over dt, which is known as areal velocity. The second law by Caplar talks about areal velocity, that is dA over dt, how fast or slow this area is changing with time. This areal velocity, and we'll also know that this areal velocity is constant. This is the law. And the areal velocity comes out to be L over 2m, that we'll also discuss afterwards. L is the angular momentum and m is the mass of the planet. It's L over 2m. This also is important. Now we'll discuss about the third law, law 3, which talks about the time period, that is called as law of periods. Law of periods. What is that law? It states that the square of the time period of planet, I'll write the statement here, planet is directly proportional to cube of major axis. This is the statement. Means what? The square of the time period of planet is proportional to r cube. That we have already discussed from the expression that t square is 4 pi square over gm r cube. Because this is a constant, so t square is some constant r cube, or t square is proportional to r cube. This is self-statement. But semi-major, R stands for semi-major, but this relation can be applied for circular orbits as well. This is applicable for circular as well as elliptical orbits. In case of circle, we don't have to think of R, that is the radius. R is the radius. In case of ellipse, then we have to think of this one. This is known as the semi-major axis. So here, in case of ellipse, this relation is semi-major axis, that is this distance that we have to take. Otherwise, the relation is same. So these are the 3 laws. Then we'll go to some other videos. Okay. So for the timing, thank you.